Good morning, students of the A1 A2 class. My name is William Vu, and I will be doing a presentation on stem cells. So, with the history of stem cells dates back to 40 years ago when originally scientists discovered the existence of stem cells in mouse embryos. We then transferred this knowledge to human embryos in 1998 and have since then been using them in laboratories for several testing purposes. In 2006, we discovered that we could actually genetically reprogram normal adult cells to act as uh, stem cells instead of harvesting from embryos. As you can see, or as you will learn, it will avoid a lot of controversy. Since 1998, we've since been expanding our knowledge on stem cells as it helps our healthcare system. The idea of stem cells is that they are cells that can be grown into whatever kind of tissue that is needed. Essentially, they are harvested and then grown in a laboratory and developed into whatever kind of tissue that is needed in the healthcare system or for testing. There are four different ways that stem cells are harvested. Primarily, they can be found within the embryo of a human mother, or there are certain kinds of adult stem cells found within bone marrow or other parts of the body in which these cells are quickly made and usually transform into a different kind of cell after it is well produced. iPSCs, or induced pluripotent stem cells, are regular stem cells that are genetically reprogrammed to act as adult stem cells. And in amniotic fluid, i.e., within the umbilical cord, we have found that there is an amount of stem cells that we can also harvest. It's small, but it's a change instead of just, harvesting from the embryo itself. So there are five different types of stem cells. The totipotent stem cells is what is within the embryo. It usually is what is becoming the human baby. Pluripotent stem cells is what is becoming of the outside of the embryo. The membrane that covers the embryo is usually what scientists will harvest instead to protect the baby. So after birth, the totipotent stem cells have already become the baby. After the baby is delivered, the scientists may instead harvest the pluripotent stem cells. The multipotent stem cells are adult stem cells that are transforming into different other kinds of cells. These are the ones that are found within bone marrow. And unipotent stem cells are the weakest, as in the weakest of the five, as in they are the least tangible and the least useful, as they can transform into the least kinds of others of tissues. These are the iPSCs. No, excuse me. These are not the iPSCs. The iPSCs are their modified pluripotent stem cells. The unipotent stem cells are man-made, but as much as this is a classification, its existence is not quite well known. We have an idealized usage of stem cells. More specifically, we want to let scientists experiment with the effects of disease on these body systems. So we may have stem cells that develop into tissues that mimic organ systems, for example, bones or blood vessels or nervous cells or um, any part of the human immune system. We can have stem cells that develop into these type of tissues and then test diseases on them to see the progression of diseases and how it affects these different body systems. Excuse me. The use of stem cells to make specific tissue, because we are always in a lack of organ donors. This is probably our best act in that we can, instead of using organ donors, we can instead just make the tissue ourselves using these stem cells. And also drug testing, for example, a certain kind of medicine that could affect a certain body part. We could test this on a man-made body part instead, and really no harm is done here. So this is really just dragging on to the previous diagram, but as it stands, the embryo is, well, it's fertilized, and then as it develops into multiple cells, uh, it will then become this larger embryo. And when the middle is hollowed out, you get these inner mass cells, and these inner mass cells are usually what scientists will harvest, and then these are the stem cells that we usually use to make, well, the tissue for different organs. There is a lot of controversy within stem cells because of how they are harvested, and that's simply because in harvesting stem cells from the human embryo, you are destroying it. And scientists will only ask consenting mothers, but at the same time, it is essentially an abortion. Although an abortion itself has kind of has a negative connotation, this one is for the goodwill of science and also just for further development of healthcare and sciences. What it seems to be the issue here is that um, a lot of mothers will. The thing is that the embryo can only be developed for around 3 to 5 days when these stem cells are still harvested. Otherwise, a baby is, or at the smallest form of a baby is formed, and therefore it's just impossible to get those stem cells back as they have already developed into tissue for the baby. What we can do, however, is after the birth, we can harvest the stem cells that surround the embryo, but it is a very low amount, and therefore scientists they'll still harvest it. It's just not nearly as much, and therefore less efficient. But of course, we do not want to force a mother to perform an abortion for the sake of science. And the reason that we usually perform this kind of act is because the three other ways that we get stem cells have their own problems. For example, adult stem cells, they cannot transform into every type of tissue that we will usually look for embryonic stem cells to transform into when we are testing. Amniotic fluid has too few stem cells, and iPSCs, it's new technology and not tested enough. Fortunately, since then, scientists have developed stem cell lines. These are eggs that are fertilized in a laboratory. And this is a much better option because this is not technically considered an abortion because it hasn't been implanted within a mother. It has been grown outside a womb and therefore is not an abortion. Instead, it's like a man-made stem cell, but it still acts as an embryonic stem cell. And here are my references.